Okay, I'd like to try to finish up section 1.2 in this video here. So we're on problem 18. Determine the next most probable term in the list. So let's just kind of verify that these equations are true. 1/2 equals 1/2. Okay, if you take 1/2 plus 1/6, get your common denominator there. So 1/2 the same as 3/6. Plus 1/6, that's the same as 4/6. 4/6 reduces to 2/3. Okay, so the second equation is true. If you have the third equation, 1/2 plus 1/6 plus 1/12, then my common denominator would be 12. So 1/2, that's the same as 6/12. 1/6, that's the same as 2/12, plus 1/12. Add the numerators there. It's be 9/12. 9/12 reduces to 3/4. That's true. Okay. And all right. So based on what we see here, what's the next probable equation going to be? Well, it looks like on the left, for each term, I've got a 1 in the numerator. Okay. So I'm going to have a 1 there. And in the denominator, I need two numbers that are right next to each other. And just from the pattern that I see above here, it looks like whatever that last number is, for us it's a 5, I want the number right next to that, which is 6. So 1/5 times 6, and that would be equal to, the right side, you're going to take the number on the left, which is 5, divided by the number on the right, which is 6. Okay, so equals 5/6. Part B, determine a formula in terms of n based on the pattern that we see in part A. Okay, so based on these equations, and then find the sum, 1/2 plus 1/6 plus 1/12 plus etc. plus 1/90. Okay. Well, based upon what we see here in this this pattern, it looks like we've got 1/2 plus 1/6 plus 1/12 plus etc. plus 1/90, two numbers that are right next to each other. Okay, call the smaller one n, and whatever the big one is, it's going to be right next to it. So let that be n plus 1. Okay, 1/n plus 1. Okay, and that'd be equal to n divided by n plus 1. So if n is 5, I got 5 divided by 6. If n is 4, I got 4 divided by 5. If n is 3, I got 3 divided by 4. So whatever that last fraction is in the denominator is going to be key for us. Okay, and so here'd be the formula that we need. Okay, now what if we want to find 1/2 plus 1/6 plus 1/12 plus etc. plus 1/90? Well, the only thing that I'm interested in here is 90. Okay, everything else is not relevant. So I need two numbers right next to each other that multiply to be 90. Okay, lots of things multiply to be 90. But two numbers that are right next to each other, well, if I use 9 and 10, 9 times 10 is 90. 9 is going to go in the numerator. 9 plus 1 is 10, so that's going to go in the denominator. Okay, and of course I can check this to see if that is true. Problem 19, determine the next most probable equation in the list. Okay, so 1 is equal to 1, 4 is equal to 2 squared is 4, 9 is equal to 3 squared is 9, 16 would be equal to 4 squared is 16. Okay, 1 plus 3 plus 5 plus 7 plus 9. 16 plus 9 is 25. 5 squared is also 25. Okay, so that's true. Now I want to determine a formula in terms of n based on the pattern from part A. Okay, and then find the sum 1 plus 3 plus 5 plus etc. all the way up to 99. Well, it looks like from above there, I'm adding up a bunch of odd numbers. Okay, so I got 1 plus 3 plus 5 plus 7 plus 9 plus etc. Now I'm going to leave this last term alone for the moment. And now on the right side, I'm just squaring a number. Okay, so there's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. Okay, so what if it's n squared? Well, the last number that we have in terms of n on the left should be 2n minus 1. Okay, and let me check that for what I have here. So if n is 5, okay, 2 times 5 is 10, minus 1 is 9. Okay, what if n is 4? Okay, 2 times 4 is 8, minus 1 is 7. What if n is 3? 2 times 3 is 6, minus 1 is 5. Okay, so it looks like, whatever that last number is, I want to double that and I want to subtract 1, just as a general formula. Now, suppose that we want to use this formula to find the sum 1 plus 3 plus 5 plus etc. up to 99. Well, so the thing to see here is that, now if I had 1 plus 2 plus 3 plus 4 plus etc. all the way up to 100, that would be 100 counting numbers. Okay, half of them are going to be even, half of them are going to be odd. I've only got odd numbers here that I'm adding. So 50 of them are going to be odd, 50 of them are going to be even. Okay, in other words, there's 50 numbers here on the left. 50 squared gives you 2,500. Okay, so 2,500 would be the answer for 1 plus 3 plus 5 plus etc. plus all the way up to 99. Okay. Now, so what we're doing here, by the way, is we're establishing a pattern, and the nice thing about establishing a pattern is that I don't need to waste time trying to figure out what 1 plus 3 plus 5 plus 7 plus 9 plus I don't care about that. I just figure out how many numbers I got, and there's 50 numbers there, so 50 squared is 2,500. 2,500 is the answer. Okay, so we're trying to find the answer to this sum, but faster than just adding directly. Okay, so keep that in mind. The last thing in this section is some things over figurate numbers. Okay, and so problem 20, determine the next most probable term in the list. You got 1 plus 3 plus 6, or 1, 3, 6, 10, 15. Okay, the next number would be 21. Okay, and to see that, 1 to 3 is I added 2 to 1. 3 to 6, I had to add 3 to 3. 6 to 10, I had to add 4 to 6. Okay, and then I had 5 to 10. Okay, now if I add 6 to 15, I get 21. Okay, now this list of numbers is called triangular numbers, and we just found the sixth triangular number, which is 21. Some notation here that you'll see in the book. Capital T sub 6 represents the triangular number, the sixth one, which is 21. Now I want to determine the formula in terms of n to find the nth triangular number. Okay, so n times n plus 1 divided by 2. Well, that's a formula that we should know, by the way. If I were to add n counting numbers, it's n times n plus 1 divided by 2. Okay, so what if I were to add the first 100 counting numbers? Well, n is 100 times n plus 1, that's 101, divided by 2. 100 divided by 2 is 50. So it's going to be faster to multiply directly. 50 times 101 gives me 5,050. Okay, so this formula is not a new formula, is what I'm getting at. Capital T sub n is equal to n times n plus 1 divided by 2. Okay, let's verify that when n is 6. If n is 6, I get 6 times 7, that's 42, divided by 2 is 21. Okay, what if n is 10? 10 times 11 is 110, divided by 2, gives me 55. Okay, now the nice thing about knowing t sub 10 is that I don't need to know t sub 9, I don't need to know t sub 8, I don't need to know t sub, I don't care about those. Okay, the nice thing about having a formula is I can find, the sum directly for whatever n is. Okay. Problem 21, determine the next most probable term in the list. So you get 1, 4, 9, 16, 25. Okay, so the thing to see here is that these are square numbers. Okay, so 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared is 36. Okay, and the numbers that I just said are called square numbers. We just found the 6th square number. Determine a formula in terms of n, and then find the nth square number. Okay, well, s sub n represents the nth square number. There's no mystery to this formula. I'm just squaring numbers. Okay, so n squared would be what I get. When n is 6, 6 squared is 36. Okay, so s sub 6 is 36. What if I want to know s sub 10? 10 squared is 100. Okay, and the nice thing about knowing s sub 10 is that I don't need to know s sub 9, I don't need to know s sub 8, I don't need to know s sub 7. Like, I don't care about those numbers. Okay, I can just find s sub 10 directly. Problem 22, determine the most probable next term in the list. 1, 5, 12, 22, 35. Okay, this list is going to require using the method of successive differences. And so if I arrange the numbers in a somewhat spaced form, and always take the right number minus the left number. Okay, so 5 minus 1 is 4, 12 minus 5 is 7, 22 minus 12 is 10, 35 minus 22 is 13, 51 minus, 13. So 7 minus 4 gives me 3, 10 minus 7 gives me 3, 13 minus 10 gives me 3. Okay, and I keep doing this until I get a row that's producing all the same number, and I've got that. So I'm going to assume that this bottom row here continues where I got all 3's. Okay, so if I stick another 3 there, 16 minus 13 is 3. And if I add 16 to 35, I get 51. Okay, so 51 would be the 6th pentagonal number, I'd say. Okay, and that's what this list of numbers are, pentagonal numbers. We just found the 6th one. Okay, so p sub 6 equals 51. That represents the 6th pentagonal number. Determine a formula in terms of n to find the nth pentagonal number. Okay, so this is not a formula that I would expect you to see off the top of your head, so I'm just going to tell it to you. P sub n, you're going to take n times 3n minus 1 divided by 2. Okay, verify this when n is 6. So if I take 6 times 17 divided by 2, well, 6 over 2 is 3. 3 times 17, yeah, that's 51. Okay, how about when n is 10? Okay, if I take 10 times 29 divided by 2, 10 times 29 divided by, 10 divided by 2 is 5, so what is 5 times 29? 5 times 29 is 145, if you were to check that. Okay, and again, then, the nice thing about knowing p sub 10 is that I don't care about p sub 9, p sub 8, p sub 7. Okay. Now, the type of numbers that we are finding here are called figurate numbers, okay? Triangular numbers, square numbers, pentagonal numbers, etc. Can be geometrically explained by the arrangements of the points that are shown below. Okay, so I've got some points here, triangular numbers. So there's 1, there's 3 points, there's 6 points, there's 10 points. I've got the number directly underneath, 15 points. Okay, so I'm producing a figure within the same figure within the same figure within the same figure is the idea. Okay, the homework in this section is on page 16, section 1.2, so you guys should be able to have a go at the problems there.